Hello, good people. Did you know it would be very easy to compute indices if you understood all the laws of indices? And do you know that indices or the laws of indices only apply when the bases are the same? But do you know even what is a base? Well, in this kind of an expression, then A forms the base. M forms what we call the power, or simply exponent. And then K forms the number. So A to the power of M equals to K. So A is the base, M is the power or exponent, K is the number. So for the laws of indices to apply, the base must be the same. That is the first thing you must understand. But before we go to that, how many laws of indices did they teach you? Well, let's see. The first law of indices, which we need to note, the simplest, which is taught in junior school. Law number one is basically law that involves multiplication and addition. Simply have, if you are given a number A to the power of M multiplied by a number A to the power of N, then this will be, okay, let's see, M plus N. In other words, if the bases are the same, you add the powers. That is the first law of indices. The second law of indices, suppose we are multiplying. We have a number A to the power M divided by a number A to the power N. Then symbol, what do you have? M minus N. In other words, division goes with subtraction, multiplication goes with addition. We have another law, law number three. Now, the first two laws are very common and most of the people know that. Now, let's see. Is this a common one? Let's see. The third law of indices, which you might have, we have, let's say have a number A to the power of a fraction like that. Then this is the same as saying, if you take the nth root of A to the power of M. Now, I want you to note something, that this third law is what makes us to understand nth root. For instance, square root, like for instance, if you want to talk about square root of a number, like the square root of a number A is the same as simply saying A power half. The cube root of a number A is the same as saying A power a third. The fourth root of a number goes in the same similar scenario. In that case, 3 here presents the nth, and then 1 here presents the 1, and that's basically what happens. Let's look at law number 4. In the law number 4, we have, suppose you're given a number which is raised to a power M, and then the whole of this is to power N. This, using indices, simply means that we have A M multiplied by N, equivalent to simply saying A M N, because Mn here means multiplication. Law number 5. Law number 5. Oh, did you think there were 3? No, we still have more. So, law number 5, if you are given a number A to the power of a negative N, I refer this one as law of reciprocals. This is the same as saying 1 all over A to the power of N. What has happened to the negative? The negative automatically disappears in that sense. That is, I refer this one as law of reciprocals. Law of reciprocals. For instance, if you are given a number, let's say you're given a number 3 power negative 2. This is the same as saying 1 all over 3 power 2. And the same thing can be applied to if you are given a number A all over, let's say 4. Say we have 1 over 4 to the power of a negative 2. This is the same as saying simply 4 power 2. 4 power 2. The negative disappears like that. So that is another law of indices. Then I move on to law number 6. Law number 6. Suppose you're given a number to the power of 0. The law says that any particular number given to the power of 0 will always be 1. Now, just look at how many laws we have. 6 good laws to guide you through when you're doing questions concerning indices. Now, just something to note. These are the same laws which are going to help us to come up with what we call the laws of logarithm. See you in the next video as we look at that, laws of logarithms, before we start looking at some other examples. Thank you.